Here is an application of product rule. I want to differentiate the following, and here I have p of x equals x squared plus 1 times x to the negative 1 plus 1. And I could FOIL this out, but just for the sake of illustration, I'm going to use product rule, and it's important to identify your pieces here. So I have 1 for the x squared plus 1, I'm going to call that my first piece, and 2 is the x to the negative 1 power plus x to the first power for my second piece. Okay, so now when I want to calculate the derivative, remember the rule is 1 d2 plus 2 d1. Okay, so I need to keep that in mind with these pieces respectively. Alright, so that's going to be x squared plus 1 times the derivative of the second, which would be, using power rule, I have negative x to the negative 2 plus 1. Alright, so that, again, here, that's 1, and this is d2. Okay, now I have plus the second, which is x to the negative 1 plus x, times the derivative of the first, which is just 2x, plus the derivative of 1, which is 0. And so again, here, this is d1 right there, and this is 2. Okay, now you have now taken the derivative correctly. However, you may want to try to do some algebra to simplify this. So at this point, I am going to do some foiling here. So my first term, I have x squared times the negative x to the negative 2, which would give me a negative x to the 0. That's going to simplify just to being negative 1. Alright, so again, if you didn't see that, that's these first two terms. And then I have the outside terms. So I have an x squared times 1. So it gives me an x squared. On the inside, I have a negative x to the negative 2. I cannot add these two middle terms together. And lastly, I have a plus 1. Alright, now in the second set, I just need to distribute 2 to the x, or 2x, sorry. So 2x times x to the negative 1, which is right here. I just need to distribute the 2x across here. 2x times x to the negative 1 would just be 2 times x to the 0. And then I have a 2x squared. So now when I simplify, let's see, I have 3x squared. I have a negative x to the negative 2. And then my constants, let's see here. What is constant? That's negative 1. That's a positive 1, so those 0 out. And then that's 2 times 1, so that's another 2. So I have plus 2. And here is my derivative. And this is the simplified version. Okay, so again, this is correct, or actually this up here is the correct application of product rule. This is a more simplified version that may be what your professor would like. Now as a second example, I have h of t equals the square root of t times t to the 1/3 plus t to the negative 1/3. And it's useful, remember, to think of the square root of t as t to the 1/2 power. So now when I take the derivative here, I'm going to say the first, which is t to the 1/2, times the derivative of the second, which would be 1/3 t to the 1/3 minus 1, be careful with the arithmetic, that's negative 2/3, minus a 1/3 t to the negative 1/3 minus 1, again be careful with the arithmetic there, that's a negative 4/3. So this is 1 and d2, like that, okay? So now we need 2, which is this t to the 1/3 plus t to the negative 1/3 times the derivative of the square root of t, which would be 1/2 t to the 1/2 minus 1, negative 1/2 power. Alright, the algebra here can get a little dicey, but we'll just see what happens. We're going to distribute the t to the 1/2 across the first two terms, and 1/2 t to the negative 1/2 across the second two terms. And I'm just going to do my arithmetic to the side here, because remember, when I have h prime of t, for example, when I multiply these first two terms together, I get 1/3 t to the, I have to add my exponents, 1/2 minus the 2/3. Okay, so I'm just going to show you the arithmetic there real quickly, and then we'll simplify these exponents. Okay, so here we have the arithmetic now, and so I can see here, for example, t to the 1/2 times 1/3 t to the negative 2/3 by adding those together, I get t 1/3 t to the negative 1/6 power. Then I have a 1/3 t to the 1/2 minus 4/3. That's going to be a negative 5/6 power. Now on the other side, I have a 1/2 t to the 1/3 minus 1/2. That's a negative 1/6 power, plus a 1/2 t to the negative 1/3 minus 1/2, negative 5/6 power. So lastly here, I can combine some things again using some arithmetic. I have a 1/3 plus 1/2. That's going to be a positive 5/6 t to the negative 1/6. And then I have a negative 1/3 plus 1/2, which gives me a positive 1/6 t to the negative 5/6. Oof, that was ugly, but here it is. Okay, so this again is the correct application of product rule, and this part was what makes calculus hard, is algebra. So in general, algebra is what makes these questions difficult, not the formula, but you have to be proficient in both. Okay, I hope this makes sense. Let me know if you have any questions. I'm going to do another video on quotient rule, so be looking for that. And if you need any help, again, let me know. And thanks for watching.